smart city is an urban area that utilizes various types of electronic data collection sensors to supply information used to manage assets and resources efficiently. These data are collected from citizens, devices, and assets that are processed and analyzed to monitor various aspects within a city, for example, in terms of transportation, waste management, and many others. These information are integrated to make a city smart by using it to help make people's life easier and solve various urban issues and to promote sustainable living, which goes hand in hand with sustainable development goals. 5G is being centered on the idea that the Internet of Things, that is, connected devices, will become very important in the near future. With many devices requiring mobile networks in the future, we will need not only faster overall speed but also lower latency. Plus, with greater bandwidth, it will have faster download speeds and the ability to run more complex mobile internet apps. It also boasts theoretical speed of 20 gigabits per second, which is faster than any other connections today. However, why do we need 5G and how is it better than 4G? Although 4G is pretty fast with about 100 megabits per second, 5G will be able to multiply current 4G speeds many times over, such as having a speed range between 1 to 10 gigabits per second and just 1 millisecond of latency round trip, and a 90% of reduction in energy usage and a huge increase in bandwidth. 5G can help improve a city by instilling itself into applications to make it work smart in a city. The first application that is to be implemented in smart city is driverless cars. Driverless cars is a robotic vehicle that is designed to travel between destinations without a human operator. It communicates with other cars around it that are in range by broadcasting their speed, steering wheel position, brake status, distance from one another, and other relevant data. This communication is ensured with vehicle to vehicle communication. Vehicle to vehicle communication, or V2V, is a wireless network that sends information and data between vehicles about what they are doing and their surroundings to sense if there is any danger approaching their vehicle and avoid it. How does V2V communication work, you may wonder? Well, V2V is a mesh network which is where every node is able to send, capture, and retransmit signals quickly, that there will be more than enough time for even the most distracted driver to take his foot off the gas. V2V communication also uses a dedicated short range communications DSRC, which is intended for highly secure, high speed wireless communication between vehicles and the infrastructure. We believe that DSRC is a good wireless installation in the driverless car as it permits very high data transmission in communications between the vehicles. Also, because it operates in the 75 MHz band, it will be able to provide a clean, unrestricted communication environment between vehicles to ensure that the communication is not interrupted or deterred halfway. This will ensure that the vehicles will be able to have a 360-degree situational awareness. Users do not need to worry about sharing their vehicle information with other vehicles, as the V2V system will not collect, broadcast, or share personal information, nor does it permit tracking of specific drivers or their vehicles. It only exchanges generic, anonymized safety information. Also, the birth of driverless cars will increase the efficiency of users as they will have more time and energy during long traveling, as they are able to do their work in the car or even relax with their family during the journey. Other than that, the rate of accidents will decrease in the city, and this ensures the safety of the citizens of the city. The second application that is to be implemented in smart city is smart bin. What is the need for smart bins when there are trash cans, right? Well, smart bins is here for a reason, and that is because it has IoT technologies instilled into it that provides visibility on solid waste management, efficient waste management, communication with server and route planning, and visibility of waste bins for garbage collection. Technologies such as GPS tracking system, IoT sensors along with mobile and web applications are implemented in this concept to improve and smoothen ground level mechanisms for waste collection and efficient processing and recycling of waste. How does it communicate, you may ask? Smart Bean uses client-server architecture to connect all the smart beans to a server where the status of the dustbin will be stored. The garbage collection truck will then access to the server to receive updates. This is where part of peer-to-peer can be implemented inside the client-server network in order to speed up communication process. The connection can be achieved by allocating one peer to act as an agent, which acts as a facilitator of the communication network and offer other peers a service to interact with the connected server. Because of this self-managing, there is no need to configure the agent peer as it acts like a proxy fox for the main server, thus making the server an extra service in the peer-to-peer network. We believe that the implementation of Smart Bin can help to support speedy access and efficient retrieval of data, as the sensors in the bin will help to inform the garbage truck drivers on which bins are full and need to be collected at every part of the city, which saves more time than the need to go on rotation to check all the bins, whether full or empty. Smart bins also help to boost recycling efforts as waste materials will be separated when the garbage trucks unload the rubbish. However, there are some limitations of smart beans whereof each particular network will be overridden by the alternative network. By having the IoT technologies instilled, the cost of developing and maintaining the smart beans will be high as there are so many of them around the city. Other than that, since smart bean relies on connectivity to allow client-server communication, any issues with the network will affect this communication and this will disrupt the transmission of data between client and server. The third application that is to be implemented in smart city is smart street lighting. Smart street lighting is becoming the platform for a wide variety of smart city modernizations as it provides safer traffic conditions and safer pedestrian environment as there is a large number of sensors and IoT devices integrated to ensure there is a client-server communication. A very important feature of smart street lighting is that the control algorithm can be different at different points on the same network. Connecting streetlights together in a computer-controlled network enables a wide range of innovative capabilities and enhances the performance of the lighting system. In streetlights, we have the transmission control protocol, which is basically a network protocol that defines the route of data sent and received through network communication hardware for the street lighting to communicate. In TCP/IP, the application layer contains the communications protocol and interface methods that is used in process-to-process communications across an internet protocol computer network. Smart lighting also uses the TCP connection for fast retransmissions. However, we believe that smart street light may need more upgrading and working on because since there are many manufacturers involved in smart lighting industry, there will also be many different communication patterns that are implemented by different brands of products, and because of this they may not be able to interoperate with each other. The main reason for this is that they have low compatibility and extensibility, whereas TCP protocol has high compatibility and extensibility. Therefore, we suggest that there should be either a standardization in all smart street light or a new protocol that is developed that is able to communicate with different communication patterns by different brands of products. In conclusion, as 5G has yet to exist, all the applications we mentioned above are just our suggestions on how we can improve the current technology within a smart city by incorporating 5G. By incorporating 5G into the technologies we have mentioned, many change measures has to be taken as the current network is unsuitable to match the fast network speed of 5G. 5G will help cities to stay connected faster and with a stronger connection as it is estimated that 5G will have a wider network coverage than what we have today. Cloud-based technology can also be implemented into the Internet of Things in order to support the fast network speed in 5G, and this is known as Cloud of Things. There are various modifications which can be made in the current existing networks in order to make them more suitable to support the upcoming 5G technology. By achieving 5G networks within a smart city, this will help us to be able to achieve the sustainable development goals within a smart city in order to improve the current standard of living. The next decade promises breakthrough developments in several technologies, and 5G will take the world to almost a new and different place from where we are right now. Thank you.